guys, my name is Chloe. I'm a year 4 business student. So today I'm gonna share with you about this algorithm called Boyer-Moore algorithm. It's a pattern searching algorithm. So I'll just tell you like how it works and how it's related to our class. So basically, you have a text and a pattern, and the objective of this algorithm is to look for the pattern instances of it in the text. So unlike other algorithms, it compares the characters from right to left, so opposite of how we read. And it's more efficient than comparing character by character because it skips the unnecessary comparisons by using two different approaches, the bad character heuristic and the good suffix heuristic. Heuristic is just another word for rule. So yeah. So I mentioned that it compares from right to left. So this is how it starts. It looks at the number of characters that the pattern has. So for example, if you're trying to look for the pattern madam in the string of text there, we first see that there are 5 characters. So we then look at the text in the same aligned with the last character of the pattern, and if it doesn't match, we know that the pattern won't appear from the first index. But if it does, then we hop backwards to see whether it matches up. And so the first heuristic, the bad character heuristic. So the essence of this is that whenever you hit a mismatch, right, it tries to find a correct match as quickly as possible. So to illustrate this, there's a chunk of words there, but I'll just show you. So we take the pattern madam and this line of text again. So we can see that the letters in green are the ones that are matched up, and the letters in red do not match up. So what this rule tells us is that we're gonna take the letter M and we're gonna try to find it in the pattern. And if we see that M occurs in the pattern, which it does, we're gonna shift it to the right until we get what we have in step 2. So we actually skip one unnecessary comparison, so to say. And over here in step 2, we see that the letter K is the one that is mismatched. But in the pattern, there's no letter K. So what this rule tells us is we just shift the entire pattern to the right so that we skip past the letter K. So then because we know that in between the pattern can't occur in any of the positions where there is K, so that is what it does. Following so far, yeah? Okay, anyway. Then the second heuristic is called the good suffix heuristic. So previously what it did is it takes the mismatch and it tries to make it a correct one as efficiently as possible. This one, it keeps, so it looks at what you already have matched and it's gonna keep it and try to keep on matching that or make the length of the match text longer so that you can generate larger skips across the text. An example would be, let's say we're looking for the pattern anana in this text or this string of words. We see now we will call the 2 matched words, which is N and A, we call it T. And we're going to try to see whether the pattern has another instance of NA where we can push it to the right. Because as you can see in the letters in the red, they don't match up already. So what this good suffix heuristic does is they match these 2 up and it slides it to the right. And now NA becomes our new T. And you would think like, oh, then where else am I gonna find another set of NA? So according to this rule, what you would do next is to look at the pattern and see whether any parts of it, doesn't have to be green, matches up in the text that's represented by T. So if you look at it, we see ANA that is in both, that is circled in both the pattern and text. So this represents like another opportunity for us to like skip unnecessary comparisons and shift it to the right. And upon doing that, you get this, and it just so happens to match up. So the algorithm works based on these 2 heuristics, these 2 rules. And then if you didn't really get like the illustrations, the general concept of these 2 rules is that the bad character heuristic tries to change the wrong match into a right one as quickly as possible, while the good suffix heuristic keeps the correct matches and tries to lengthen the length of it so that you don't have to keep making comparisons from the beginning over and over again. And when the algorithm runs, what it does is it simply picks the heuristic that skips more unnecessary matches. So what we end up with is an algorithm that becomes more efficient the longer the pattern is. Because remember all the way to the first step, I mentioned that we start by looking at the last character and seeing whether it matches with the text in the same position. So if let's say you have a pattern you're looking for that's 100 characters long, as long as the last letter doesn't match, you know the first 100 characters, like, it won't work for you already. So that's how you move on. Instead of like what they call like the naive algorithm, where they go letter by letter, so they go left to right. So for example, if you're looking for the word cat, it goes C. Is this word C? No. Is this word C? Yes. Then is the next word A. So that takes like a much longer time. So the longer the pattern, the faster this algorithm works, which is why I found it interesting. However, the downside of this is that for very short patterns that are repetitive, like for your DNA sequencing, this is one of the most time-consuming algorithms to produce results. Likewise, if the pattern isn't found in the text, it also takes very long to tell you the pattern is not in the text. So yeah, as for the applications of this, anyone think on the top of your head like an application of this pattern searching in our everyday lives? Like whenever we Control F, right, there's like something that we are searching for already. So in your everyday like text editors, in the daily lives of a uni student, we actually use this kind of we have a need for this kind of function quite often, but at least now we know the name of this algorithm behind it. Yeah. So that's the end of my presentation. In case right you didn't understand like the examples that I gave, this is a tiny URL for like a site I found. It gives like visual animations of how this process works. So you can type in a pattern you want and like a list of text, and it shows you step by step how this algorithm will determine where it finds like the pattern line in the text. So that's all. Yes? Okay, thanks guys.
Okay, thank you. Okay, you all have to rate her. You all will hold, right? No, okay, anyway, go to eLearn. Go to eLearn and I forgot to switch off the preview just now. You know what? So what happens is that now you are seeing, and if you look into the screen, you see a screen, and then into the screen you see a screen. This is called recursion.